In last class, we have discussed the problem on root locus, that is 17 scheme question paper we have discussed. Today we shall discuss the 15 scheme question paper in the same year, February, March 2020-22. But the scheme is 15 15 scheme. Okay, the subject code is different. So the open loop transfer function of a control system is given by g of s equals to k divided by s into s plus 2 s square plus 6s plus 25. Sketch the complete root locus as k varies from 0 to infinity. The same question in here, the open loop transfer function of a control system is given by g of s equals to same equation. Okay. First step, what you need to do is to find out the step poles. Okay, so you can observe here s equals to 0, s equals to -2, and from this you will get two roots, that is -3 plus or minus j4. So how many poles are there? 4 poles are there. And what about the zeros? Here z equals to 0 because no zeros are there. Okay, and n equals to p minus z, so you will get 4 branches. So n equals to p minus z. So 4 branches approaching to infinity. The starting points are this one and the terminating points are infinity. Next is section of real axis. Section of real axis. If you hold here, it is 1 root and 2. Okay, so 2 is a even number. No root locus exists between here infinity to -2. When you stop here, if you from here to here, there is only one pole, that is 0. So it is a odd number. 1 is a odd number. So root locus exists. Root locus exists and the breakaway point exists between -2 and the 0. Between 0 and -2, a breakaway point exists. Next, we need to find out the angle of asymptotes. So here the number of branches is 4. So you need to find out the 4 angle of asymptotes, that is theta 1, theta 2, theta 3, theta 4. So while solving for theta 1, you need to substitute q as 0. Okay, you need to substitute q as 0 for theta 1. So for this, q equals to 0, and for this, q equals to 1, and for this, q equals to 2, and for this, q equals to, it is 3. Okay, so when you substitute these values, you will get the theta 1, theta 2, theta 3, and the theta 4. Okay. Next, we need to find out the centroid one. Okay, we need to find out what centroid. So centroid equals to what? Summation of real poles minus real summation of real part of open loop poles minus summation of real part of open loop zeros divided by p minus z. So here the root is here -3 plus or minus j4. So -2, -3, -3. Okay. So 0, -2, -3, -3. So -6 -8 divided by 4 -2 you'll get. Next, breakaway point 1 plus g of s h of s equals to 0. Here the h of s value is 1. So 1 plus g of s, the given question is write down this g of s value, h of s value is 1. So when you take out the LCM, so this will come to the numerator and the denominator will go to the right side. It will become 0. So when you solve that equation, you will get this s to the power of 3 plus 8 s square plus 37s plus 50 plus k equals to 0. So k equals to, if you take out to the right side, minus s to the power of 4 minus 8 s to the power of 3 minus 37 s square minus 50 s. So when you differentiate with this s, what you'll get? Minus 4s cube minus 24s square minus 74s minus 50 equals to 0. So we got that s equals to what value? We got minus 0.898 we get. And the other two roots are complex. So we have neglected that other two complex part. Okay. Other two roots are complex. So we have not taken and the s equals to minus 0.898. If you substitute in the this equation instead of s, if you substitute this value, so you'll get the value of k equals to plus 20.2. It is a valid breakaway point. Okay. Next to step 6 is the you need to find out the yes value, okay, intersection with the imaginary axis. So what we have taken in the step 5, that equation only you consider, this equation only you consider. Okay. So here we need to write, it is actually s to the power 4, and it is s to the power 4 plus 8 s square. Okay, s cube, this is 2. So when you solve this equation, okay, this is s to the power of 4 actually, okay, and this is s to the power of 3, okay, and this is 37 s square, and here minus 50 s, okay. It is mistake. You can write s to the power 4, 8 s cube, 37 s square, 50 s plus k equals to 0. That is the equation we get. Here, same equation you consider for the step 6. Okay. So from this A0 value, okay, next to A2 value, and next to the A4 value. Again, this 8 here and the 50 here. So next 8 into 37, 8 into 37 minus 50 into 1 divided by 8, 30.75. Next 8 into k minus 0 divided by 8. So you will get the value k. Next to 30.75 into 50 minus k into 8 divided by 30.75. This is the, okay, from this, from row s to the power of 1, that is 1537.5 minus 8k equals to 0. So k marginal equals to what value you will get? 192.1875. Here of s equation. Before that, what equation is there that you consider? 30.75 s square plus k equals to 0. We know the value of k. Substitute, get the value of s. Okay, s equals to plus or minus j 2.5 you'll get. Square root of this 6.25 is nothing but 2.5. Next, here the complex part is there in the starting. Okay, this is the complex part. So angle of departure is required. Okay, so angle of departure we need to find out. Here the roots are like this, the poles are like this, 0, okay, 0 and the minus 2, okay, minus 3 plus j4, minus 3 minus j4, okay. We are considering now minus 3 plus j4, okay. So this is the point, and we have intersected all, we need to join all the poles, okay, we need to join all the poles. So this is the one pole. So this we need to join, okay, sorry, this angle we need to find out, and the second pole is minus 2. This angle also we need to find out. So phi p1 equals to 180 minus tan inverse of, okay, this tan inverse of 4 divided by 3. Okay. For example, this is the protector. We know the, this is angle phi p1. Okay. So this from, this is nothing but theta. Okay. This is nothing but phi p1. So overall is 180. So this is 180 minus, okay, 180 minus theta. The theta can be written as what? Tan inverse of opposite value. Opposite means this value, this is nothing but opposite. Okay, opposite value is, it is similar to here, so it is a 4. Okay, and the adjacent value, this is the adjacent value. Okay, this is the adjacent value. What we can write, adjacent value 3 from here to here. Okay, so the value what we get is 126.86. Okay, similarly we need to consider for here 5p2. Okay, so the 5p2 is here. Okay, 180 degree minus tan inverse of, from here to here, how much it is? This value is 2 and this value is 3. Okay, so minus 3 minus 2. The value is, adjacent value is 1, because it is adjacent value. We are considering this angle. Okay, so my tan inverse of 4 divided by 1, 104. And 5p3 value we can write directly 90 degree. Summation of 5p. So 90 plus 104 plus 126, that you add 320.89. 5z is 0 because there is no zeros in the numerator of in the given question. 5 equals to 5p minus 5z equals to 320.89. 5d equals to 180 minus 320.89. You will get the value, negative value, that is minus 40 minus 140.89 at minus 3 plus j4. So what value you get, this is the answer what we get, and you should write opposite to this. So if we get minus 140, you should write plus 140.89 and minus 3 minus j4, because we have now what we have done is this coordinates is minus 3 plus j4. Okay, plus j4. Okay, so we have found out the angle of departure for minus 3 plus j4. What we get the angle opposite to that, minus 3 minus j4. For that you need to write down the opposite value. Now we shall draw the graph. Okay, so first we need to mark the poles, that is poles 0, minus 2. Okay, minus 2, 0, minus 2. Next, what we got, the centroid point. Centroid point is minus 2. Okay, centroid point is minus 2. Here the centroid point is minus 2. So this is the centroid point. You can observe. Okay, this is the centroid point. So from this you need to mark the theta 1, theta 2, and the theta 3 and the theta 4, right? After marking centroid, you need to mark the angle, that is asymptotes, you need to mark them. Next, breakaway point. Breakaway point, how much we got, that is s equals to minus 0.898. Okay. So we got that breakaway point is minus 0.898, that they have taken as 0.9. Okay, this is the breakaway point. That means this 0 is flowing like this, and the minus 2 also flowing like this, and the what we got, the imaginary intersection with the imaginary axis, we got that is plus or minus j 2.5. Okay, so first mark the j 2.5, plus or minus j 2.5. Okay, here from breakaway point, this 0 will go like this. Okay, 0 will go like this and it will terminate at the infinity. Next, this from minus 2 root, this will terminate at the here. Okay, it is, which is parallel to the asymptote line. This will also terminate at the infinity. This will also terminate at infinity. Okay. Next, we have a complex pole. Okay, we have a complex pole. That is, we have a complex pole. First, for complex pole, angle what we got, phi d. phi d equals to minus 140.89, that you mark down. This is the angle what we have written here. Similarly, plus 140.89. Okay, so this root, it will flow like this, and it will terminate at infinity like this. Okay, and similarly here also this angle, what we minus 3 and the plus j4, it will flow like this, and it is also flowing like this, and it will go to the infinity point. Okay, so now the starting points and the terminating points are infinity, 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 infinity. So the four poles are terminating at the infinity. Two poles are terminating, it is intersecting the imaginary axis, and the two poles are it is parallel to the asymptote line. All the lines, root locus line, are parallel to the asymptote line, but here what happens is the imaginary part is which is not intersecting the imaginary axis. Okay, what is complex part is there, the complex pole is not intersecting the imaginary axis, it is directly, it is going towards infinity without touching the imaginary axis. It is in the left half of the S plane only. Okay, this is the question they have asked for 14, sorry, it is asked for 12 marks. Okay, in next class we shall discuss with the other questions.